To access and manage any Kubernetes resource or object in the cluster, we need to access a specific API endpoint on the API server. Each access request goes through 3 stages: authentication, authorization, and admission control. First, let's talk about authentication. Authentication just means logging in a user. Kubernetes does not have an object called user, nor does it store usernames or any related details in its object store. However, even without these, Kubernetes can use usernames for access control and request logging. Kubernetes has 2 kinds of users: normal users, which are managed by outside services which are independent to Kubernetes, like user client certificates, a file listing usernames and passwords, or Google accounts, etc. The second kind of user is service accounts. With service account users, in-cluster processes communicate with the API server to perform different operations. Most of the service account users are created automatically via the API server, but they can also be created manually. Service account users are tied to a given namespace and mount the respective credentials to communicate with the API server as secrets. If properly configured, Kubernetes can also support anonymous requests along with requests from normal users and service accounts. User impersonation is also supported for a user to be able to act as another user, a useful feature for administrators when troubleshooting authorization policies. For authentication, Kubernetes uses different authentication modules. Let's go through them one by one. The first one is client certificates. To enable client certificate authentication, we need to reference a file containing one or more certificate authorities by passing the client CA file option to the API server. The client certificate authorities mentioned in the file would validate the client certificates presented to the API server. The second one is static token file. We can pass a file containing predefined bearer tokens with the token AUTH file flag to the API server. Currently, these tokens would last indefinitely and cannot be changed without restarting the API server. Next are bootstrap tokens. This feature is currently in beta status and is mostly used for bootstrapping a new Kubernetes cluster. Next is static password file. This is similar to static token file. We can pass a file containing basic authentication details with the basic AUTH file option. These credentials would last indefinitely and passwords cannot be changed without restarting the API server. Next is service account tokens. This is an automatically enabled authenticator that uses signed bearer tokens to verify the requests. These tokens get attached to pods using service account admission controller, which allows in-cluster processes to talk to the API server. Next, OpenID Connect tokens. These help us connect with OAuth2 providers such as Azure, Active Directory, Salesforce, Google, etc. to offload the authentication to external services. Next comes webhook token authentication. With webhook based authentication, verification of bearer tokens can be offloaded to a remote service. The last one we'll be discussing is authenticating proxy. If you want a program additional authentication logic, we can use an authenticating proxy. So these are some of the authenticating modules that could be integrated with the Kubernetes. We can enable multiple authenticators, and the first module to successfully authenticate the request short circuits the evaluation. In order to succeed, you should enable at least two methods: the service account tokens authenticator and one of the user authenticators. After authentication comes authorization. Authorization, what we do is we authorize the API request added by the logged in user. After a successful authentication, users can send API request to perform different operations. Then those API requests get authorized by Kubernetes using various authorization modules. Some of the API request attributes that are reviewed by Kubernetes include user, group, extra, resource, or namespace, just to name a few. Next, these attributes are evaluated against policies. If the evaluation is successful, then the request will be allowed, otherwise it will be denied. Similar to the authentication step, authorization has multiple modules or authorizers. More than one module can be configured for one Kubernetes cluster, and each module is checked in sequence. If any authorizer approves or denies a request, then that decision is returned immediately. Let's discuss some of the authorization modules. We'll be looking at 3 of these authorization modules in this episode. The first one is Node Authorizer. This is a special purpose authorization mode which specifically authorizes API requests made by kubelets. It authorizes the kubelets read operations for services, endpoints, nodes, etc., and write operations for nodes, pods, events, etc. The second authorization module is Attribute-Based Access Control Authorizer, or ABAC authorizer. With the ABAC authorizer, Kubernetes grants access to API requests which combine policies with attributes. The last one is Webhook Authorizer. With the Webhook Authorizer, Kubernetes can offer authorization decisions to some third-party services which would return true for successful authorization and false for failure. After authorization comes admission control. The final topic that we'll be discussing in this episode is admission control. Software modules can modify or reject the request based on some additional checks like a preset quota. Admission control is used to specify granular access control policies, which include allowing privileged containers, checking on resource quota, etc. We force these policies using different admission controllers like resource quota, default storage class, always pull images, etc. They come into effect only after API requests are authenticated and authorized. To use admission controls, we must start the API server with the enable admission plugins, which takes a comma delimited order list of controller names. Kubernetes has some admission controllers enabled by default. So this is it for this episode. Honestly speaking, I've made these just for myself, but I realized that there are people who are listening to these episodes and they are probably interested in some of the Kubernetes concepts. Anyway, if you just want to say hi or you have any questions, you can write to me at kubernetes@sent.com. That is SENT.com, as in I've sent you the feedback.